Welcome to the Valve Studio, where our work on this JCM800 continues. Last time we got all the way up to a point where we had checked out all the DC operating point. We looked at the load line. We determined that we're under the plate dissipation limit of 25 watts at all voltages. And we looked at this Jupyter notebook tool that I came up with to actually look at the bias point impact of the slopes when it goes from class A to class B, and what that does in terms of integrating the power curve over one single sine wave and looking at the power dissipation from that perspective. All that aside, we got all the way through that and we found out that the two tubes that I had borrowed from Jerry had about a 6 milliamp offset between them at the operating point. So one tube was at 30 milliamps, the other one was at 36. And a lot of times that, you can live with that. Well, what if you continue to run the amplifier in that fashion? What ends up happening is that constant DC through one half of the output transformer may end up permanently magnetizing the transformer, at which point you'd have to run it through a degausser and kind of clean it up. So it's really good to have your push-pull amplifier tubes aligned in the DC bias perspective. When I talk to Jerry, he says he gets it down to a fraction of milliamps to make sure that the balance is correct. Well, we're way off. We're off by 20% because that's 6 milliamps out of 30 milliamps is 6. All right, so I have the 4 tubes now from Jerry, and I kind of, plugged a bunch of different, combinations in, and I got 2 that are very similar. Let me go ahead and show you that here. All right, here's the workbench. Over here are my 2 DC milliammeters. I have them on. They've been running for about 20 minutes. They're warmed up. The amplifier's been on for about the same amount of time, and here are my probes. My clip-on probes are actually connected between the tubes and the transformer. So we're actually only looking at the anode current itself. Most of the time people disconnect the other side, which is the cathode side, and they have to contend with the screen current. We're only looking at the anode current. All right, so let's come up here, and I have the standby switch off, so when I click it on, it's going to apply the high voltage to the tubes. All right, one tube, we're on the 100 milliamp scale. So one tube is 38 milliamps on there. And then over here, we are a little bit like 38.3 or something like that. So we're off by a fraction of a milliamp. That's pretty good balance for these particular tubes. All right, well, we got the balance right because we have the tubes picked out, but we're a little hot. Remember the Mullard engineers have a table in there that say at 425 volts for the plate voltage, you should be right around 30 milliamps. We're a little bit hot, so I'll go ahead and turn that back, and then I'll go ahead and set it at 30. And that ends up being 50% of the power dissipation at the operating point, not the 70%. That's that's kind of the standard, we'll say, for the way you do this. And that's going to result in longer life on the tubes in this amplifier. If we kind of kick it down, it still sounds fine. When I had my tubes in here, it was plenty loud, and I didn't have any problems with playing it kind of down there. I didn't sense it being cold. All right, so we got all that stuff straightened out. Now there's one more thing about this. This thing has a problem with the reverb circuit. Remember, I turned it up, and it's all hummy and stuff. So let's take a look at that next. This JCM800 has a problem with the reverb circuit. You turn up the gain, and all you hear is hum. I took it apart, and I got out the schematic, the preamp part of the schematic. I looked at the reverb circuit, and they have an ECC83 that drives a transformer, and that's coupled in wired directly into the reverb tank. So it's driving the reverb tank, and then the output from the reverb tank runs back into the other triode in that ECC83. And so I checked all the bias voltages, and they looked kind of okay. It's a cathode biased stage, and it was biased around 1.6 volts for the grid voltage, minus 1.6. that looked all good. So when I ended up, I shorted the input leads, basically grounded that control grid, and the hum went away. Which means to me that there could be a problem with the tank itself. I took the tank out of the amp, the head part, and I measured the output impedance, and it was right around 200 ohms. And similarly on the input stage as well. Which leads me to believe that there's some other problem. Maybe it was like a cabling problem. So I just plugged it all back in, the hum went away, and the reverb tank started working. So I'm embarrassed to say that I think it just kind of got bumped out, or it fell out during transportation or something. I don't know. Maybe. Who knows? That problem is resolved. So the two problems we had with this, the petering out after 20 minutes, as well as a problem with the reverb, those are all taken care of. So this thing is ready to get put back together. So let's just kind of summarize what we ended up doing. I took this out, and I checked the bias voltages, and I found a problem with the tubes. I borrowed some EL34s from Jerry. We found a really good match, so that those would be matched on the bias, and we checked that with the milliohm meter. We went and generated a Python notebook, and we looked at the Class A and the Class B operation and what happens when you switch between the two. We did some plotting of the power output itself, and we integrated that over a cycle. And we found that this amplifier, indeed, at all voltages, if the screen voltage is around 425 volts, at whatever the amplitude is, we're still below the 25 watt limit on the plate dissipation for the EL34. And and that's a good thing. So this is a pretty well designed amplifier, and I believe that the engineers might have they just picked right out of the data sheet for the Muller data sheet the operating point for this amplifier. It seems that was like well suited, and it's an optimized placement for the bias point. Well, I got it plugged in here. Let's go ahead and take a listen to it. I did go ahead and buy a GLS Audio ES57 microphone. I got that right in front of my 1960 cabinet. And I got one of these USB to XLR adapters. So I have the amplifier on. The reverb is turned off. Pretty much everything is set around 5, and my gain for my channel gain, the boost gain, is right around 3. So it sounds really nice. Not too loud in here. Let's turn up the gain a little bit. Let's turn it back down. It's very loud now. I'll go ahead and show you that the reverb's working. Well, I think this is ready to get put back together. Put it back in the case, tuck it all back together, screw it back together, and do a check on it. So, this is the Valve Studio. Thanks for watching.